Very good morning to my dear students. Today I would like to deliver the topic about virtual memory management. In this virtual memory management, we have some subtopics. Those are virtual memory, demand paging, demand segmentation, paging consideration, virtual memory. Virtual memory, which is nothing but it is a storage allocation scheme in which secondary memory can be addressed as through it were part of the main memory. Actually, it is the size of the virtual storage is limited by the addressing scheme of the computer system, and amount of secondary memory is available not by the actual number of main storage location, and it is a technique that is implemented using both hardware and software, and it maps memory address used by a program called virtual address. It is the part of program needs to be memory for execution, and it have the logical address space can therefore be much larger than the physical address space. Allowing address space is to be shared by several processes and allows for the more efficient process creation, more program running concurrently, and less input output needed to be loaded as swapped process. What are the virtual memory components? The virtual memory components are main memory and disk. This main memory, it consists of a number of fixed length of frames, each equal to the size of the page. For a program to execute, some or all its pages must be in main memory. See this picture, it is the main memory and it is the fixed length frames as we observe the picture of main memory. And disk which is nothing but secondary memory can hold many fixed length pages. A user program consists of some number of pages, and pages of all program plus the operating system are on the disk are files. See here, you observe the disk picture. Here the user program A and user program B is there. Those are the secondary memory. In virtual address space, it is a logical view of the process stored in memory and usually start at the address 0 and continues address until end of the space. Meanwhile, physical memory organized in page frames, the memory management unit must map logical to the physical, and virtual memory can be implemented demand paging and demand segmentation. So demand paging, which is nothing but the process of loading the page in memory on demand. Demand means, as usual we called, demand means the name itself, whenever the page faults occur is known as demand page. Okay, and based on the paging segmentation, a process may be broken up into pieces, that is pages or segments, to do not need to the located continuous in main memory. Based on the locality principle, all the pieces of the process do not need to be loaded into main memory during execution. All the address are virtual. The memory referenced by the virtual address is called virtual memory, and it is mainly maintained on secondary memory, that is disk. The pieces are brought into a main memory only when needed. See here, it is the example of virtual memory. Okay, this is the virtual address space. The virtual address spaces are 0 to 4K, 4K to 8K, and 8K to 12K. So in between it is in 0 to 64K. And next, those are the virtual pages. So all are the virtual pages. See this picture, how it will be mapped in page frame. So Initially the pages will be start. So here virtual means which is nothing but image dual. Okay, see here it is mapped with in physical memory address how it will be applicable. See here the initially it starts with 0 1 2 3 4 5 6 and 7. Here the frames are 0 to 7, that is 8 bits. Here will be taken. Here virtual memory having the virtual address having 64 kilobit 64 bits. Okay, see here the 0 of will be mapped here. Okay, and 1 will be mapped here 0 1. Okay, 2 3 4 5 6 and 7. 7 is mapped here. Okay, see here how it will be mapped. 0 will be mapped here. 1 check here. 1 be mapped here and 2 is mapped here and 3 is this 3 is mapped here and 4 this 4 is mapped here and 5 this 5 is mapped here. 6 this is mapped here. This 7 is mapped here. See here this one is mapped again. I explain. 0 is mapped here. Okay, 1 is mapped here and 2 3 4 and 5 6 and 7 is mapped here. See here this is the virtual memory management, physical memory and physical memory storage here. In this virtual memory it having the pages of page 0 1 2 and so on page n, and it will map with the memory mapping by using a physical memory. It will be stored as physical map of memory map. So this is the physical memory. Here the virtual memory is larger than the physical memory. So physical memory is small when compared to the virtual memory. The advantages of partial loading. More process can be maintained in main memory. Only load in some of the pieces of each process. With more process in main memory, it is more likely that a process will be in ready state at an given time. Okay, a process can now execute even if the larger than the main memory size. And here the two advantages is here only loaded in some of the pieces of each process, and it is maintained in the main memory, and the process can now execute even larger than the memory size also, and it have the more bits to use logical address than the bits needed for addressing the physical memory. And virtual memory is large as your wish. For example, if we take the 16 bit are needed to the address physical memory of 64 KB, let use a page size of 1K so that 10 bits are needed for the offset within the page. For page number part of the logical address, we may use the number of 6 bits larger than 6, say 22. It is modest value assume 32-bit address. For example, if we needed a 60-bit needed address, a physical memory 64, okay, and 1 KB, so that 10 bits are needed for the offset within the page. And in larger logical address, we may use a number of bits larger than the 6, and it is say 22 and assuming 32 bits. Okay, supported needed for the virtual memory. Here it is supported hardware and software by using of paging or segmentation, and the operating system must be able to manage movement of the pages or segments between external memory and main memory, including the placements and replacement of pages and segments. See this picture, it is the virtual memory addressing. In this virtual memory addressing, here we use the process memory management unit, main memory and secondary memory. So the process send virtual address to main memory management unit. If it is a real address, it will be moved to main memory. If it is a disk address which is nothing but secondary address, this secondary address means it will be moved to secondary memory. Okay, see here the virtual memory addressing means here they will be checked to real address or disk address. It is the image. See here the process will send the virtual address to main memory management unit. In this, it is real address, it sends to main memory, or if it is a disk address, it sends to the secondary memory. The main memory will send to secondary memory. Okay, this is the virtual memory addressing. And virtual address space, it is designed for logical address space of stack to start to maximum logical address and grown down while heap grows up. Okay, and its maximum address spaces are used. Unused address space between two is whole. No physical memory needed until heap or stack grows to the given new pages. Okay, and here it will be used system libraries for shared via mapping into virtual address space. Shared memory by mapping pages are read and write into virtual address space. Paging can be shared during fork spending and process creation. So by using of sharing, the functions will be used. See here, it is 0 to maximum. See this picture, it is the 0 to max. Down 0 it have the code, data and heap, and stack is there, and the address space with holes are left to grow dynamically linked libraries. Shared library using virtual memory. See this picture, shared library, the name itself, shared library means whatever the library functions we can use to share using virtual memory. See this picture here, the shared library will be used to one to another by using of shared pages. One to another by using of shared pages. And process execution in virtual memory is the operating system as usual. The main memory, only a few pieces of program. Each page or segment table entry have valid or invalid bit, that is a set of corresponding pieces in main memory. The resident set is a portion of process that is the main memory in storage. As usual, the process execution will be done. చెప్పాలంటే మెయిన్ మెమరీలో మనం ఏదైతే పీసెస్ ప్రోగ్రామ్స్కి పెట్టి ఉన్నామో అవన్నీ కూడా స్టార్టింగ్ పాయింట్ నుంచి ఎండింగ్ పాయింట్ వరకు కూడా అక్కడ ఏమవుతాయి అంటే వ్యాలిడా ఇన్వాలిడ్ బిట్ చెక్ చేసుకుంటాం. వ్యాలిడ్ బిట్ ఇన్వాలిడ్ బిట్ అని ఎలా చెప్పగలుగుతున్నామంటే మనం ఏదైతే పేజ్ టేబుల్లో ఎంట్రీ చేసామో డేటా అనేది వ్యాలిడ్ అయితేనే వీగా తీసుకుంటాం. ఆ డేటా అనేది వ్యాలిడ్ కాదంటే ఇన్వాలిడ్గా తీసుకుంటాం. వ్యాలిడా ఇన్వాలిడా అని ఎలా చెప్పగలుగుతున్నామంటే వ్యాలిడ్ అంటే ఇఫ్ దెర్ ఈజ్ అ డేటా ఇన్ పేజ్ టేబుల్ దెన్ వ్యాలిడ్. Invalid ante if there is no data in page table, that we can call as invalid data. Okay, so each and every piece the program execution లో మనం మెయిన్ మెమరీలో ఉన్న ఈచ్ అండ్ ఎవ్రీ పీసెస్ని కూడా మనం ఏం చేస్తామంటే రెసిడెన్స్ సెట్గా కాల్ చేస్తాం. ఈ రెసిడెన్స్ సెట్ అనేది ఏం చేస్తుందంటే ప్రాసెస్ అనేది మెయిన్ మెమరీ సమ్ స్టేజ్ వరకు తీసుకెళ్తుంది. కొన్నిసార్లు మెమరీ ఫాల్ట్ వల్ల ఎలాంటి ఇంటరప్ట్స్ అన్న అక్కరైనప్పుడు అదేమవుతుందంటే జనరేటెడ్ వెన్ ద మెమరీ రిఫరెన్స్ ద్వారా మెమరీలో లేకుండా దట్ ఏదైతే ఫాల్ట్ మెమరీ ఫాల్ట్ వల్ల కొన్ని ఇంటరప్ట్స్ అక్కడ అవుతాయో అది మెమరీ లేకుండా చూసుకుంటుంది అనమాట. అలాగే ఏదైనా ప్రాసెస్ అనేది బ్లాక్ స్టేట్స్లో కూడా పెడుతుంది. అట్ ద సేమ్ టైం ఆపరేటింగ్ సిస్టమ్ అనేది ఏం చేస్తుందంటే ఇన్పుట్ అవుట్పుట్ రిక్వెస్ట్ని మెయిన్ మెమరీకి పీస్ రిఫరెన్స్ ద్వారా పంపిస్తూ ఉంటుంది. అలాగే ఇంకా వేరే ప్రాసెస్ ఏమన్నా డిస్పాచ్ అయ్యాయి అనుకోండి, వాటిని రన్ చేయాలి అన్న డిస్క్ ఇన్పుట్ అవుట్పుట్ టేక్ ప్లేస్ తీసుకుంటారు. ఓకే, మోస్ట్ ప్రాపర్లీ మనం ప్రీవియస్గా చెప్పుకున్నట్టు ప్రాసెస్ అంటే విచ్ ఈస్ నథింగ్ బట్ ఇట్ ఈస్ ద కలెక్షన్ ఆఫ్ టాస్క్. ఓకే, సో ద టాస్క్ కంప్లీషన్ ప్రాసెస్ వీ కెన్ కాల్డ్ as a process, or program completion process we can call as a process. ఓకే, సో ఈ ప్రాసెస్ నెంబర్ ఆఫ్ ప్రాసెస్ అని ఉండొచ్చు, మల్టీ ప్రాసెస్ ఉండొచ్చు. అలాంటి సిచ్యువేషన్లో ఒకటి చేస్తున్నాం కదా అని ఇంకోటి ఆగిపోవడం అనేది జరగదన్నమాట. అలా జరగకోకుండా కంటిన్యూస్గా డిస్పాచ్ చేసుకుంటుంది. దీనికి ఇదే వర్చువల్ మెమరీ అనేది యూజ్ చేసుకుంటుంది బై యూజింగ్ ఆఫ్ కరస్పాండింగ్ ప్లేసెస్ ఇన్ మెయిన్ మెమరీ. నెక్స్ట్ demand paging. As earlier I said, the demand paging, which is nothing but the process of loading the page into memory or memory on demand. So whenever a page fault occur is known as demand page. Okay, bring a page into memory or only when it is needed. So if it is needed, less input output is needed, no unnecessary input output, less memory needed, faster response, more users. So when we use the demand paging, less input output needed, no unnecessary input output, less memory needed, faster response, more users. And page is needed means reference to it. I said invalid reference means abort, just leave it. Okay, not in memory means bring to memory. Okay, similarly the page system with swapping, a lazy swapper never swaps a page into memory unless page will be needed, and the swapper that deals with the pages into the papers. Valid bit and invalid bit. How we calculate the valid and invalid bit? So valid bit means present and invalid bit means absent. It is shaded in associative memory. Okay, invalid bit and valid bit and invalid bit is set as invalid bit or initially valid bit are set as I. Okay, and valid bit means we set as V. See this picture, you can clearly observe here frame and valid or invalid bit is there. If the data is there, then we put V. If the data is not absent, if there is no data which means absent, we put I. Okay, and during the address translation, if valid and invalid bit is page entry is I, so that I is page fault. Virtual memory mapping example. See this picture, this is the example of virtual memory mapping. Here outer going physical address, it is inner going physical address. So the outer going physical address is like this one, and the inner virtual physical address is this one. Okay, the value is this. Here we mapped page table by using of 0 to 15 means 16 bits will be taken, and here we read the data based on here 0 1 0 0 0 0 0. If there is no data, we put 0. If there is a data, we put 1. Okay, see here, so 0 means invalid data, 1 means valid data. Remember that 1 equal to valid, 0 means invalid, represents I. Okay, So see here, we write by using of incoming virtual address and outgoing virtual address. We need to fill these bits in our virtual page, and it is the indexed page table also. See here, we check it is present or not, the bit is present or not. Here in outgoing physical address, having the first three is 1100. Okay, and where it is 1100 is stored in second page. Okay, 1100 is present, so the bit is present. Okay, then it will be moved to here. Why? Because we check all the combinations of binary of incoming and outgoing physical address, so that will be moved out. So clearly observed, if there is no data means it is 0 0 0. See here, 0 0 0, there is no data. If it have the data, we put 1, remember that. Okay, and it is the 12-bit offset occupied by the directly from input to output. Okay, that is offset is 100 and 100. The page table, when some pages are not in main memory, if some pages are not in main memory, then what happened, which will be explained here. Okay, see this logical memory and page table, physical memory is there. Okay, in this logical memory, it having 8-bit data, so that is 0 to 7, so it filled with A to H, A to H. Okay, in this page table, the frame numbers will be calculated by using of 0 having 4 and 2 having, let we assume these numbers. If you are interested, you can write any numbers here. Okay, and 5 have 9. మనం మాత్రమే అనుకుంటున్నామమ్మా. ఫర్ ఎగ్జాంపుల్ ఇక్కడ మనం 469 కనుక మ్యాప్ చేస్తే ఏం జరుగుతుందని. ఈ 469 రాయాలా అంటే అలా రాయాలని ఏం లేదు, మీ ఇష్టం, యాజ్ యువర్ విష్. ఓకే, హౌ మెనీ బిట్స్ ఇక్కడ మీరు తీసుకున్నారో వాటిని బేస్ చేసుకొని ఇక్కడ చూడండి, వ్యాలిడ్ బిట్, ఇన్వాలిడ్ బిట్ అని 2 బిట్స్ మనం తీసుకున్నాము. చూడండి, నేను ఇక్కడ ఏం చెప్తున్నాను, ఫ్రేమ్ నెంబర్స్ రాస్తున్నాను, ఇవి పేజ్ నెంబర్స్ 0 1 2 3 4 5 6 7 అనేవి పేజ్ నెంబర్స్. ఎందుకు పేజ్ నెంబర్స్ అంటున్నా అంటే లాజికల్ మెమరీలో మనం పేజ్ నెంబర్స్ తీసుకున్నాం. అయితే ఫ్రేమ్ అడ్రస్సింగ్ ఏమి ఇస్తున్నాడంటే 0కి 4 ఇచ్చాడు, 2కి 6 ఇచ్చాడు, 5కి 9 ఇచ్చాడు. రిమెంబర్ దట్ మనం ఏమేమి తీసుకున్నాం, 4 6 9ని మ్యాప్ చేస్తున్నాం. ఇప్పుడు చూడండి, ఇవి వ్యాలిడ్ బిట్ ఇన్వాలిడ్ బిట్ అని ఎలా డిక్లేర్ చేస్తామంటే ఫ్రేమ్ నెంబర్ అనేది అక్కడ ఉంటే కనుక మనం వ్యాలిడ్గా తీసుకున్నాం, అలాగే ఫ్రేమ్ నెంబర్ అనేది అక్కడ ఏమీ లేకపోతే ఇన్వాలిడ్గా తీసుకున్నాం. సో వ్యాలిడ్ని ఎలా రిప్రజెంట్ చేస్తాం, వీతో రిప్రజెంట్ చేస్తాం. ఇన్వాలిడ్ని ఎలా రిప్రజెంట్ చేస్తాం, ఐతో రిప్రజెంట్ చేస్తాం. See here, 4 is valid and in page 1 there is no data, so it is invalid. In page 2 it has 6, then it is valid. In page 3 there is no data, it is invalid. In page 4 there is no data, it is invalid. In page 5 it have the data of 9, so it is valid. In page 6 there is no data. In page 7 there is no data, so we put I. Okay, and it has a physical memory, clearly observed here, it has a physical memory. In this physical memory we will be mapped by using of logical memory and page table. How it will be mapped, see here, the 4 frame having page 0 means, so whatever the page 0 having the data that will be placed. సో పేజ్ 0 వాట్ ఇట్ హ్యావ్, ఏదైతే మనం 4 ఫ్రేమ్ నెంబర్ చూస్తున్నామో ఆ పేజ్ నెంబర్ ఎక్కడ సేవ్ అయింది, అది ఇండెక్స్లో అంటే పేజ్ 0 దగ్గర 4 అనేది సేవ్ అయింది. ఓకే, ఆ పేజ్ 0 దగ్గర 4ని పెట్టాలి అంటున్నాం. అయితే ఆ పేజ్ 0లో ఏముంది, ఏ అని ఉంది. సో పేజ్ 4 ఫ్రేమ్ 4 దగ్గర ఏం చేస్తున్నామంటే ఏ ఫిల్ అవుతుంది. ఓకే, అట్ ద సేమ్ టైం ఇక్కడ చూడండి, పేజ్ టేబుల్లో 6 ఇన్ పేజ్ 2 అంటున్నాం. సో 6 దగ్గర ఏం పెట్టాలి, పేజ్ 2 పెట్టాలి. పేజ్ 2లో ఏముంది, సి ఉంది. సో 6 అనేది పేజ్ సిలో పెట్టాం. నెక్స్ట్ చూడండి, 9 ఉంది డేటా. 9 అనేది ఎక్కడ ఉంది, పేజ్ 5లో ఉంది. పేజ్ 5లో ఏముంది, ఎఫ్ ఉంది. సో 9 దగ్గర ఏం పెడుతున్నాం, ఎఫ్ పెడుతున్నాం. ఓకే, హ్యాష్ అండ్ ఇట్ విల్ బి మ్యాప్డ్ ఆఫ్ వర్చువల్ మెమరీ of main memory is like this. So what all we will be taken in logical memory. So the logical memory all is filled with here A B C D E F G H. Okay, all it is filled. The physical memory whatever it will be needed, that must be only it filled. And dynamics of demand paging, it is typically each process has own page table. See here, the virtual address is page number and it has offset also, and the page table is entry of frame numbers, p equal to present bit and m is modified bit. Each page table entry consists of valid and invalid bit, what I said in previous, and it is the main memory. That entry contains the frame number of corresponding pages in main memory, and the main memory may consist of PCB, and PCB which is nothing but process control block. Dynamics of demand on paging means here it is a modified bit indicated of the page has been allowed since it was last loaded into main memory. If no changes can be made and it needs to swap out. Okay, and control bits may be present of protection of manager at the page level. A read only and read write bits will be protected, and the protected level bit is kernel page or user page. See this example needed for the page fault or replacement. Here logical memory user 1, logical memory user 2 is there. So user 1 having the page table, user 2 having the page table is there. In this we will be used 4 pages, that is 0 1 2 3, and logical memory user 2 having 4 pages, that is 0 1 2 3, and it have the data of logical memory H load M, the M will be loaded, so J and M, and user 2 have A B D E. Okay, and in page table having the frames are 3 4 5, so the valid invalid bit VVI, and the frames have 6 to 7, so then it will be in, if it is the data valid, if it is no data it is invalid. See here how it will be mapped physical memory. So it will physical memory will be take 0 to 7. Here the 2 page 3 having so page 3 having 0 1 2 0 1 2 3. Okay, 3. See here 0, the page 0 having the data of H, so where it will be filled 3 H will be filled. Okay, and 4 means the page 1, the page 1 having data is load M, the 4M have load M. Okay, and page 5 having the data page 5 means 2 J, so the 5th frame will be filled with J. Okay, and in page user 2 it having 0 6 having data A. Okay, and 2 having D, the same time 7 having E, all are filled. So need for page fault means here the load M means the M of data is be loaded. Where it will be loaded? In main memory. In main memory will be loaded. So the user of first page and user 2 of first page both all are in main memory. But here we not taken in physical memory of B. Where it is B? We not ఇక్కడ మనం బీని మాత్రం తీసుకోలేదు చూడండి ఫిజికల్ మెమరీలో. సో రెండు ఎక్కడ ఉంటాయంటే రీప్లేస్ చేస్తాం. ఎలా రీప్లేస్ చేస్తామంటే మనం ఈ లోడ్ ఎంలో ప్లేస్లో పైన ఉన్న వాటిలో ఎక్కడో చోట రీప్లేస్ చేయడం కోసం పేజ్ ఫాల్ట్స్ అనేవి అక్కరైనప్పుడు మనం ఇలాంటి ప్రొసెసర్ ద్వారా వాటిని ఓవర్కమ్ చేస్తాం అన్నమాట. Okay students, in this class section we learn a basic concept on virtual memory unit. In that virtual memory unit, how it will be implemented in hardware and software we learn in this, and how it will be mapped with virtual address, and what is the page faults is there, and when we use the demand on paging, in that demand on paging, how it will be implemented by demand of segmentation, and page fault, how we find out the page fault. So all the things we learn in this section. In next section we continue the topic. Thank you students.